Alright guys, welcome back to our second recording of Quadratics. I know that one of my videos seems to have gotten deleted, so I'm going to mix all of these into one video. I apologize that this one's going to be long, but remember you don't have to watch the whole thing in one given night. Alright, so let's go ahead and introduce how to graph a quadratic function with an XY table. Alright, so our first lesson is going to be graphing a quadratic function. This is a quadratic function using an XY table. And again, we're going to actually extend this a little further. Like I said, this is going to be kind of two different lessons in one, so this video might be about 15-20 minutes instead of 10. But graphing a quadratic function using an XY table is going to be based on our standard form. So our standard form of a quadratic function is our ax squared plus bx plus c. All right? And that's just our standard form, just like you would have with any other shape. And what you're going to get when you graph a quadratic function is you're going to get a u. It may be facing upwards, might be facing downwards. Let me use a different color for this. Let's see, it might be facing downwards. Not really sure. It just depends on your given problem, but it could be an upward facing, down facing, however you want. It could be over here as well. It doesn't have to be over on the right. I just happen to draw both of mine on the right. Alright, and what you're going to do, just like you did with a line, so when you guys learned how to graph a line, y equals mx plus b, all you did was you stuck in some kind of x, you tested it out in here, so you replaced your x with, say, 1, replaced it in all of this, and then you got a y value. Okay, we're going to do that as an example, so don't worry if that doesn't make sense just by me saying it. This will actually be part of probably the easiest part of this lesson, so I don't think anybody will struggle with this. All you're going to do is we're going to use this as our example, f of x, and remember I could just say that y equals, but I'm going to say f of x because it stands for a function. Every quadratic function is a function, it's kind of in the name. So f of x is equal to, and what was the example I used before? It was 3x squared minus 12x plus 6. Alright, and if we match that up with our standard form up at the top, you'll notice that we actually have it in the same format of ax squared plus bx plus c. Your a was that first leading coefficient, okay? And I'm going to go ahead and I'll use brown to represent that a, so let me draw over that. Alright, so your a is going to be that first leading coefficient, or in this case it's going to be this 3, okay? Your b, on the other hand, is that second coefficient. That's your linear part. Alright? So you'll notice that each of these parts represents something. These are going to be three different parts. Sorry, I'm slurring my words a bit. But that first problem is that x squared. That x squared stands for your quadratic. So if you see that x squared is your highest degree, that's going to be your parabola. This x to the first represents, just like in y equals mx plus b, that was x to the first as well. This is your linear part, okay? So let me go ahead and write that down. So this is your linear part. Let me get the brown marker back. And this was your quadratic part. And this last value, we'll use purple to represent the last value. This last part over here was your constant part. It's just a number. Normally it's a positive or a negative number of some sort. It can be a fraction. It's just some number that's tacked on at the end. There is no variable. Okay? So if we go back and we take a look at these, that would make your second number, your negative 12 here. That would be your B. And then your C would be this positive 6 tacked on at the very, very end. Okay, and I know it's kind of hard to notice that it's purple. I'll try not to draw over blue with purple. It didn't work so well. But that is going to be your constant part. That's your C, there's your B, and there's your A. Alright, we're just going to make our XY table now. I sure wish I had a black marker to write. Oh well, that's okay. So we're just going to make our XY table. So here's X, here's Y. Alright, and we're going to test some values. A lot of students will test all sorts of different values. I'm sure some teachers have told you certain things. Typically what you want to test 4 different things. You want to test 0. So these are things you want to test, okay? You want to test 0. You want to test a fraction. Then you want to test a positive number. I'm going to shorten this to pos number like that. And you want to test a negative number. I'm going to shorten that to neg number. Okay, so those are typically the four things you want to test if you really want to be thorough about graphing what you're doing. But I know that those are often hard to work with. Like fractions, when you're squaring fractions, it does make the problem a little bit harder. Positive and negative numbers. Some people just don't like working with negative numbers. Maybe you're not so great with keeping them straight, so I understand why you'd want to avoid it. I'd say the only one of these that you absolutely have to do is a zero. Outside of that, the rest is kind of just guess and check. The idea is just to get a graph that includes everything, and sometimes you'll end up with only half a graph and you won't know what to do, so you'll know what to go the other way. I'm actually going to show that now, how we're going to go ahead and pick some numbers. I already know that some of them aren't going to work out, but we're going to do that for purposes of our example. Okay? So I'm just going to use the numbers 0, 1, 2, and 3. Like I said, I already know some of these don't work out, but I'm going to use them just for example's sake. Plus, I think a lot of students have told me that their previous math teachers have said that you would use these numbers, like these are your go-to numbers for testing things. That's actually really inaccurate. Like these are not your go-to numbers because if you use these, you're missing half the graph. You're completely ignoring the negative side of your graph. You're completely ignoring any fractions, so that could cause an issue. So it's these are really not the ideal numbers to use, but like I said, a lot of people have been trained this way, and they'll make for a perfect example of why we shouldn't use them. All right, I'm going to go ahead and plug these in. I'm going to keep using. I'm going to change colors just for kicks, really. But in our equation up here, we had our 3x squared, 12x plus 6. Let's go ahead and test 0 first. And the reason why I always say test 0, there's actually another reason. We'll get to it a little later in this lesson. But the reason you test 0 is because it's easy. So like 3 times 0, and I'll go ahead and write it out, but you guys will already be able to work this out. 0 squared is just 0. Alright, so 12 times 0 plus 6. So 3 times 0 is just 0. Minus 12 times 0 is still 0. So 0 plus 6 gives you that positive 6. So what we've gotten here is f of x is equal to positive 6. Remember your y can also be called f of x. I told you I'd use them interchangeably. So our x here was 0. When our x is 0, we tested it out and we got f of x is equal to 6. So there's that value. I don't really know why I changed colors, but at least it's colorful. It's a little less boring. Alright, now we'll go ahead and test 1. You're going to do this the same way. So 3 times 1 squared minus 12 times 1 plus 6. And 3 times 1 is just going to give you 3. Minus 12 times 1 is going to give you negative 12. And then plus 6. 3 plus 6 is 9. Minus 12 is that negative 3. So you're getting a negative 3 value for your 1. Okay, so 3 plus 6 gives you that 9. Minus 12 is negative 3. Oh, you guys can't see that. Let me go ahead and raise this camera just a touch. Sorry about that. Alright, there you go. So 3 minus 12 plus 6 equals that negative 3. And then we'll go ahead and test our 2 and 3 values as well. Your 2 value, if I plug it in, I'm not going to write these down, but if I plug in 2 here, that's going to be 3 times 4, which is 12, minus 24 is negative 12, plus 6, negative 12 plus 6 gives you that negative 6. Alright, and you'll notice here we already went from positive 6 to negative 6, so we've got a nice range here. Whenever you see that you've got both the positive and negative versions, chances are this is going to keep getting more negative, which means this next number is probably going to be a really big negative, and we probably won't want to graph it. But I'm going to go ahead and plug it in anyway. 3 squared is 9. 9 times 3 is 27. Minus 36. That's going to give you that 9. Alright, and then, oh, that actually works out pretty nicely. Negative 3. Okay, so I apologize. That didn't work out as weirdly as I thought. 3 squared again is 9, so 27 minus 36 is that negative 9. Negative 9 plus 6 gives you that negative 3. And then we'll just go ahead and graph our graph. Let's see. Alright, remember you can pause here if you need these notes. I'm going to go ahead and flip to a new page. Alright. Using what we already know, we're going to go ahead and plot those dots that we just had. Remember your points here are 0, oh, you can't see that, 0, 6, 1, negative 3, 2, negative 6, and 3, negative 3. So let's go ahead and grab a graph. We're going to put our xy up here just like this. With your graphs, they don't have to be perfect, by the way. As long as you're labeling all of your points, it's okay. Like, I completely understand if your graph isn't to scale. In fact, mine's not going to be because I'm not using graph paper, plus I'm also using these markers. So that doesn't really make it any easier. I'm just going to go about 6 out on each axis. So remember, your x-axis is your horizontal axis. That's 1, 2, 3, 4, 5. One more. 6. So your horizontal axis is your x, and your vertical axis is your y. Alright, so 1, 2, 3, 4, 5. Let's estimate that's about 6. And 1, 2, 3, 4, 5, and 6, something like that. 1, 2, 3, 4, 5, and 6. So the reason that I went 6 out on each of these is just because I noticed that my biggest values are 6 on mine. Typically, you want to keep these in single digits. Once you get up into, like, 2 comma 30, graphing 30 is kind of a problem. I'll explain that. You can go ahead. You can graph 2 comma 30, like you could put 2, go up and to the top of your page, just be like, well, that's 2 comma 30. Like I said, if you were to label your points, I'll be okay with that. All right, so just label your points, and even if it's not to scale, I won't complain. So your first dot was 0 comma 6, and we'll go ahead and switch colors for this. And 0 comma 6 is graph 0 on your x-axis, so you're not moving left or right, and you're just going to go up 1, 2, 3, 4, 5, 6. There's your first dot. It also happens to be your y-intercept. And then 1, negative 3. So here's 1, down 1, 2, and 3. So here's our dot. And then 2 comma negative 6. So here's 2. We're going to go down 1, 2, 3, 4, 5, 6. And then we'll go over to 3, negative 3. And it's just going to create this parabola. So I'm going to go ahead and draw my line through it. Oh, well, ideally you'd want to hit all of your dots. There we go. Alright, so my parabola looks something like this. This is how we estimate a graph just using x's and y's. Alright, so based on this xy table, all I did was plug in my x, some numbers that I randomly picked, plug them in my equation, and then I ended up with a parabola by plotting my dots. So I plotted 4 dots. You may have been able to make this with just 3 if you had guessed the right numbers. You may be able to make this with just 2 if... it would be hard to make it with 2, so I recommend 3 or 4 dots for this. Sometimes you might need 5 or 6. But here's the thing, it's an awful way to graph an equation this way, because you're just guessing at numbers. If I had used, I don't know, 6 over here, obviously I would have gotten, I don't know, 40 or something like that. Just a really big y value, and I wouldn't really know how to graph that. So it is a problem when you pick certain numbers, which is why this method is awful, and I don't ever recommend graphing a quadratic using an xy table. Okay? But textbook wanted me to show it to you guys. So I'm going to go ahead and move on. We're going to talk about how to graph a quadratic just based on the actual equation. So now we're just going to use this part, and we're going to take out all the necessary information. So I apologize. I know this intro part was kind of pointless, but it is in your text, and I just wanted to make sure that you had an option to see what it was that they wanted you to do. Alright, so let's go ahead and intro the actual important part, and we're going to use that standard form of equation. So you guys should remember from just a couple seconds ago, your standard form of the equation is f of x is equal to ax squared plus bx plus c. Alright, ax squared plus bx plus c, and we're still using that same formula. But now we're going to find a few things. These are the things that whenever I ask you to graph a parabola, these are the things that I'm expecting. Alright, so let's go ahead and make a little checklist. These are what have to be on a graph. So what must be on a graph of a parabola, or of a quadratic. I'll use that word. Alright, but remember, all your quadratics are parabolas anyway. Alright, so what must be on a graph of a quadratic? And those things are going to be, first, an axis of symmetry. We're going to actually show you what all of these are on a graph in just a little while. In fact, I'll use that graph that I already drew. Alright, axis of symmetry. You guys might notice the word symmetry. Symmetry just means same on both sides. So it's a line that's actually going to cut your parabola directly in half. And we'll talk about that in a sec. Let's see. 2, you'll want your vertex. Your vertex is just going to be your lowest or highest point on a parabola. Like I said, we're going to label all these things on that graph up top in just a second. Let's see, I have a brown marker. So here, you're going to want your y-intercept. Now I'm going to shorten it to y int, but oh, no, just in case you can't spell it, y intercept. All right. And then you'll have to say, let's see, I use purple, blue, green. All right. And the last thing that you'll want is your vertex a max or a min? Is your vertex a maximum or a minimum? All right. I'm going to shorten this. Oh, never mind. Sorry, I know I keep saying never mind, but sometimes I forget that people have trouble spelling. So let's go ahead and make sure that I will work those words out. Maximum or minimum. Okay, those are the four things that you'll really need for your graph. And then, of course, you'll need a graph. So do draw your line through the parabola. Let's go ahead and label what all these things are on this graph. All right, your first thing is that axis of symmetry. Again, I told you it's just going to cut your parabola in half. So it is defined in words, by the way, your axis of symmetry, and I guess I should write this down. So your axis of symmetry, by no means do you have to memorize this. This is a math class. I will never ever drill you on math vocabulary. That's not really my purpose with all of this. So the axis of symmetry in words is a vertical line that goes through the vertex of a parabola. All right, parabola. All right, it's just the vertical line that goes through the vertex of a parabola. Again, pause it if you need that. All right, so we're going to draw our vertical line up and down from here, just like that. And it cuts our parabola in half. It does go down as well, but I don't really have the room to go all the way down. All right, it's that line that just cuts it right in half. Your vertex, on the other hand, is actually even simpler. Your vertex is just that lowest or highest spot on a graph. On a given graph, that could be like this. So if my parabola looked like this, then it would be the highest point. On the other hand, in our example, our parabola is opening upwards, so it is our lowest point. But your vertex is just that lowest or highest point, and it's also where your axis of symmetry is going to go through. Okay? Next, we have our y-intercept. So our third thing is our y-intercept. And our y-intercept is just like in a line where our parabola meets our y-axis, which in this case is up here at 0, 6. So for this one, we have 0, 6 as our y-intercept. This could be anywhere. Your y-intercept could be, a negative number. It could be a positive number. It doesn't really matter. The point is where it crosses the y-axis. And in every given parabola, there is only one y-intercept. All right, and we'll talk about how to find all these things in a second. Next thing is, let's go ahead and define the difference between a maximum and a minimum. Okay, so your last question is your vertex a maximum or a minimum? A maximum is when it is the highest point of your parabola. So if your parabola opens down, you have a maximum. If your parabola opens up, you have a minimum because it is at the bottom. Over here, it's at the top. All right, max means highest, minimum means lowest. So it's actually a pretty easy definition. Let me go ahead and get all this on one screen real quickly. There we go. That is not all on the screen. There we go. Okay, so that's all of our things. Remember, your axis of symmetry is that purple line. Your y-intercept is that brown dot. It's supposed to be blue, but this dot here is your vertex. And then you know it's a maximum or minimum because it is opening up. Therefore, this is your minimum point. It's your lowest point in this parabola. Okay? Those are just the definitions of things. We're going to be able to find all of them in just a moment. So this is on screen. Feel free to pause. All right. Let's go ahead and move back, and I'm going to use that example from the other portion of our notes. We're going to use that same function, f of x. Let me change colors. F of x is equal to 3x squared minus 12x plus 6. Alright, so 3x squared minus 12x plus 6. And we did graph it earlier and everything worked out just wonderfully. Now we're going to do it without having to estimate, because if you hadn't tested randomly 0, 1, 2, 3, let's say you decided to start with -1, -2, -3, you would have ended up with much larger numbers and it would have been a mess. Okay, so remember that guess and check style, it works out sometimes, but not always. It just kind of depends on your luck. or rather, it depends on how I write it because I can write it in tricky ways. So to avoid any tricky way I can possibly write it, what you want to do is this. And you'll probably want to solve it in this order. It actually doesn't matter what order you find your vertex, axis of symmetry, y-intercept, and your max or your min. So I know I put it in this order. This is actually not the order that I find it in. It's just the order that the book happened to teach them in. So I'm going to go ahead and show you the order that I find these in. Okay, so my first thing that I determine is whether or not this is a maximum or minimum. So first, my question personally is max or min. Okay, just because this way I know whether or not my parabola is opening up or it's opening down. Okay, it's either going to open up or down. And then here's how I know. If I have a positive leading coefficient, I'm going to have an upward opening parabola, which means I have a minimum. Okay, so for my example here, this one, because 3 is positive, so if A is greater than 0, if A is positive, okay, which is probably how I should have write this, if A is positive. It's not really mathematically what I'd want to write, but that's okay. So if A is greater than 0, or if A is positive, then I have a min. Have a min. Okay, or a minimum. Alright, my vertex is going to be a minimum because when it opens up like this, and you guys remember we just graphed this, so you already have this here, and it opens upwards, which means I get that minimum. Okay, so if I have a positive A or a positive leading coefficient, it's going to be a minimum. Alright, on the other hand, if, I guess I should draw this in a different color, if A is less than 0, or rather if A is negative, that means that my parabola would be opening downwards. In which case, if it's opening downwards, let me give you an example. If it's opening downwards, then my parabola would have a vertex that is its maximum. Okay? Then I have a max. Then I have a max. Alright, so that's just how you tell whether or not it's a max or a min. Remember, for our problem, we are going to have a minimum. Alright, that's step 1. The next thing I would find here is my y-intercept, because it's actually pretty easy. So step 2 is your y-intercept. Actually, I used brown for that last time. Alright, I kind of messed up my color scheme, and I'm so sorry, guys, but that's okay. You'll get over it, I'm sure. So here we want our y-intercept. Y-intercept. I'm just going to shorten it to int for purposes of our work. Alright, and your y-intercept is actually really easy. Your y-intercept is your c value. Your c value. Okay, so you'll notice before that we actually tested 0 in and we got our y-intercept. We tested, let me see, where is that paper? When we tested 0, we got this as 6. And it's because your y-intercept is always where x equals 0. This is why I said this is the one that's non-negotiable. Where you pass the y-axis is actually one of the most important points. So you have to test 0 in all of these situations. That said, you don't really have to test 0 because in every single quadratic, 3 times 0 minus 12 times 0, it doesn't matter what numbers I put here. Anything times 0 is going to be 0, which means that you're just left with this c value, this positive 6. Okay, so your y-intercept is your c value. In this case, it's a positive 6. And remember, your y-intercept is a point, so you would write your point as 0, 6, because you didn't move left and right. Remember, that's your x, y. But you did move up and down. You moved up on the 6, and you didn't move left or right also. It's a 0, 6. Alright, so first max or min, second I do y-intercept. Feel free to pause here. I'm going to go ahead and flip to the next page. The third thing you would want to do here is your vertex formula. Alright, so third thing you want to do is your vertex formula. Vertex. And now I'm going to go ahead and give you guys a vertex formula. And that is just going to be negative b, so remember your second term, alright, all over 2 times a, your first term. Okay? So it's a negative second term over 2 times your first term. Let me go ahead and rewrite the equation on this page, that way we have it. F of x is equal to 3x squared minus 12x plus 6. Just so I don't have to keep flipping papers to refer back to it, all we're doing here is we're labeling these. Remember that first one is a, Second one, I guess we'll keep in the same color. That's going to be B. And then blue over here, we'll make C. That actually looks like a C, so let me fix that. That's a 6, okay? And we're just going to plug these into our vertex formula. And this is going to give me my x coordinate. So your vertex formula gives your x coordinate. You still have to find your y after this, but we'll go ahead and do that now. Let's go ahead and plug in our values. So negative b here. Our b was a negative 12. Oh, I wrote that in brown. So I'm going to go ahead and write a negative 12. Remember, you have to replace the whole thing. So your original equation is negative b. You're only replacing the b, so you still have to write that negative. So that negative sign is that one right there. And then you filled in your negative 12 all over 2 times a. So 2 times, and here's your a here, which was a positive 3. All right, and then we'll go ahead and work this out. A negative 12 is equal to a positive 12. Remember, a negative times a negative equals a positive. All divided by 2 times 3 is 6, which will give us, I guess I'll write this in blue, 2. So your x coordinate here is 2. So now to find your y coordinate, so this is your x coordinate. Okay. So that's your x coordinate. And to find your y, all we do is we plug that back into this equation. All right. We did this over here on this table already. Your 2, negative 6. So we already found our vertex is 2, negative 6. Again, if you didn't test 2, maybe you only tested odd numbers like 1, 3, 5, then you would have skipped your vertex here and you wouldn't have had a final answer. All right. So in this case, we already know it's negative 6. I'm going to go ahead and explain why again, but we already have the value. You're just going to take 2 and plug it back in here. All right, so 3 times 2 squared minus 12 times 2 plus 6. Again, you don't really have to do this. You can do this in your head, but 2 squared is 4 times 3 is 12 minus 12 times 2 is 24, and then plus 6. 12 plus 6 is 18 minus 24 gives us that negative 6. So we know now that this is our y coordinate. Okay? Which means that our point is, and I'll go ahead and write this in brown, I guess. Our point is 2 comma negative 6. Remember, we write it in x comma y. All right, that's a negative sign. 2 comma negative 6 is our vertex. All right. And now that we have our vertex, the last thing that we need is our axis of symmetry. Keep in mind that your axis of symmetry is a vertical line. All vertical lines have the same standard format. Where is my purple marker? Okay. So we're doing our axis of symmetry. And that is the very last thing we find. The reason we find that last is because as soon as you have your vertex, it no longer matters. Or I'm sorry, this doesn't become a problem. So your axis of symmetry, remember, it's just a vertical line that goes through your vertex. All right, axis of symmetry is just that vertical line that goes through your vertex. And let's see, your axis of symmetry, because it's a vertical line, all vertical lines, so all, I'm just going to call them vert lines for the time being. All vert lines are in the form of x equals some number here. Okay, x equals some number. So in a given example, if I had x equals 3, 1, 2, 3, that would be this dotted line. Okay. If x equals negative 3, 1, 2, 3, just up and down again. Pretty easy. All vertical lines follow the same format. It's just x equals some number. So ours is a line that goes through the vertex, which means as soon as you found vertex, you just take the x coordinate, in this case 2, okay? You solved it with the formula 2, and you're just going to say, all right, well then that must mean that x equals 2 is my axis of symmetry. So this is your axis of symmetry. Right there. X equals 2. All right, so the 4 parts of this problem that you would need to be accurate is you would need to know whether or not it's a max or a minimum. Which, by the way, if you graphed it, you'd be able to see whether or not it's a max or a minimum. But the other way to tell, if you want this answer first, and I prefer to know whether or not my parabola is opening up or down because it gives me a good thing to work off of. This is how I know whether or not I'm doing my problem right. Because if I, test some values and my parabola starts going downwards, clearly I screwed up because this leading coefficient is positive, which means I have a minimum, and which means it opens upwards. Okay? I think on the old notes I actually wrote this pretty well. Here's a diagram that might help just in case you're having trouble with max or min. Alright, so if you're having trouble understanding your maximum or minimum, here if you have a positive coefficient, your parabola is going to open up. If you have a negative coefficient, your parabola is going to open down. This here would be called a maximum, max, alright, because it's the top of your parabola. This, on the other hand, would be a minimum because it is the bottom of your parabola. Alright, so for those of you that need that, that's a graphic description of how to tell the difference between a min and a max. Alright, so you need your max or min, you need your y-int, which is just your last number over here, your c value. You need your vertex, which is given by the formula negative b over 2a. That'll give you your x coordinate, you plug it back in, and then you'll get your y coordinate. Here's your final point. And then you need your axis of symmetry, which if you've already found your vertex, is just x equals whatever this number is. In this case, x equals 2. Alright? And then when you graph it all, you'll end up with the same exact thing as over here, but you'll have gotten it every single time. So like I said, sometimes with these examples, you'll test 0, 1, 2, 3, and it'll be completely wrong because the parabola will be way out here. And if the parabola is way out here, you're going to get some massive numbers like, I don't know, 3, 120. And you really don't want to be graphing numbers like 3, 120. Alright? So you want to keep them low. This is the way to make sure that you're not just guessing and checking some numbers. Alright, so I'm going to go ahead and scroll through these real quickly at the end, just so that you guys have each of these pages as a full screen view. Feel free to pause for each page. Alright, so here is the first page. Actually, a little bit higher would work. Okay, so graphing a quadratic function using an XY table. There's a first page. Feel free to pause. I'm going to go ahead and move on to the second page. And this is the actual graph that you made from that XY table. Alright. And then we've got our list of things that need to be on a quadratic graph: axis of symmetry, vertex, y-intercept, vertex a max or a min. Again, I don't do it in that personal order, but that's how they teach it. And then here's the third page of your notes. Yep, here's the third page of your notes. So this is the order that I do it in. Alright. Oh, and the definition of axis of symmetry. But this is the order that I do it in. Your max or your min, that's step 1. Your y-intercept is step 2. So this is that third page of your notes. I'm going to go ahead and move on to the fourth page. And it's right here. So you find your vertex using your vertex formula, and then you find your axis of symmetry. Alright. So those are your 4 pages of notes for this particular just graphing quadratics. I know this video is kind of lengthy. Again, you don't have to watch it all in one go, but I hope this was helpful. Let me know if there's anything else I can help you guys with, and have a great night. I will talk to you next time.